Hello, I'm Robin Roberts and we are doing physics for grade 9 and 10. We are on chapter 6 equilibrium and I'll be solving this question 6.5 which is on page 107. So let's begin. 6.5. You have to find the tension in each cord in figure if the weight of the suspended body is 980 Newton. Now you can see over here there are three cords. There is a tension according to this cord is T1, tension along here is T2, and over here we have T3. The weight is acting downward, as you can see, 980. So this is suspended by these two cords. This cord is making an angle of 90 degrees against this one, and this one is making an angle of 45 degrees. Okay, so let's begin. So we have to calculate T1, T2, and T3. Okay, so the three tensions are this. So if I drop a perpendicular over here, you will see that if this is 45, then this too will be making 45 degrees. Okay, so along x-axis over here. So the tension over here would be, if I have to calculate this, T2 x will be equals to T2 cos theta, and T2x is equals to T2 cos 45 degrees. Okay, and cos 45, the value of cos 45 is 0.7071 times T2. Okay, so this is equation. And over here, if you look at along the x-axis over here, T1. So, and if I have to calculate before I move on to T1, let me just calculate T2y. T2y would be equals to T2 sine 45, and you know that cos 45 and sine 45 have the same value, which is 0.7071. So I'll get T2y is equals to 0.7071. Okay, now there's a weight acting downward over here. So if you look over here, this I can say that T2 or rather Ty is equals to 0.7071 minus the weight W, and W is equals to 980 Newton. Okay, there you are. And if I have to find the total value of Tx, so this would give me what is T2x? We had calculated 0.7071 minus this T1. Okay, T1 over here. So I will get T1 Tx as, yes, this one. So now you know that according to equilibrium, summation of all forces along x is equals to 0 and along y is also equals to 0. So if you calculate, if you put the value of 0 over here, I will get 0 is equal to 0.7071 minus T1. This is 0.7071 T2, okay? T2. T2 over here, T2. So I'll get T1 is equals to 0.7071 T2. Let's call this the first equation. And according to the second equation over here, we have this will be T2 y, T2, this T2. So this will be T2. Okay, sorry about that. So this will be T2. So if I put this equals to 0, yes, I'll get this equation as 0 is equals to 0.7071 T2 minus 980. So when you bring minus 980 over here, it will become 0.7071 T2 equals to 980. And when you move this 0.7071 on the right hand side, it will be divided by 980 divided by 0.7071, which will give you 1386 Newton. Okay, it will give you 1386 Newton. Now I substitute this 1386 over here, so I will get T1 is equal to 0.7071 times 1386, which will be approximately 980 Newton. So I got the value of T1 and T2. I've just calculated T1 and T2. Now, in order to calculate T3, you can see over here the tension is greater than its weight. So I can say that the tension 3 minus W is equals to the force acting on it, and according to the condition of equilibrium, this has to be 0. So T3 is equals to W, and W, is the weight, which is 980 over here. So T3 is equals to 980 Newton. Okay, just remember summation of all force acting over here should be equal to 0. Okay, along y-axis and along x-axis as well. Right, I hope it's not going to create any confusion. If you think it is, I can replace this Ty by Fy and this Tx by Fx, that is the force. I think that would be better. That you can, because I'm mentioning over here that this is Fx and this is Fy, the force acting along x-axis is this, and the force acting along y-axis Fy, as you can see, is this. So here you have one equation and this is the second equation, just to avoid any confusion. Yeah, I guess it's okay. Put the values correct. So the force acting along x-axis, all the forces should be equal to 0, and along y-axis equals to 0 in order to keep the body in equilibrium. As you can see over here, this is an equilibrium state. I hope it is clear to you all, and we'll be moving on to the next question, 6.6.